In this session, we're going to talk about the data service behind the Hello Gravity application you see here, as well as how to hook up those domain and the data service into the main application, how to link it. The application domain hierarchy for the application has been discussed in this session on domain bundles, as shown here. We're going to focus specifically on the data service in this session. And you'll see that that has two parts. There's the data service bundle, where the implementation classes live, and a data service interface, which is loaded at the top level application domain. Within the data service bundle, there's one of the classes that will be exported as a media data service service. Note here, though, that the data service bundle is reliant on the domain bundle library. We'll see that in the code. The data service projects come in a pair, the interface data service project, and the other one, the bundle for the implementation classes. Let's start with the interface. First of all, notice that it is a library Flex project, so it is in fact generating a SWIC file, data service interface.swic. Ultimately, we're going to need the SWIF file, and we'll show how to do that as linking at a later part of this session. So if we go into the source file for our interface, it's got a package, iMedia Data Service, AS. And what you'll notice for this interface is that it's basically just the CRUD operations. New, create, delete, update, and a bunch of different variations of get, based on IDs or get by ID or title or so on. So these are fairly standard operations for some sort of a data service. Note that they're all asynchronous. They're all typically returning an iToken object. Now the iToken is part of the Gravity utility framework such that asynchronous objects can register success. You can register a success or a fault handler against the token for when it's done. Now this is why you really have separated the media data service out of the domain object directly, because this part of the application is very much interchangeable. The interface, as you see it here, has no knowledge about what the actual implementation is. It turns out that in our particular implementation, we have a class that is fake data, so that we've got our own data that's standalone for this particular application. But you could quite nicely replace that with one that's talking to a live system and using exactly the same interface. The manifest file for this interface, take a look at this one. It's got a interface tag, which is what causes it to be loaded to the top level application domain. This is the SWIF, so as expected, it's the same name as our data service interface, but it is a SWIF file, not the SWIC file that this library is done. So we do rely on special linking to extract that SWIF from the SWIC file. We have declared here that this particular manifest is going to export the following service. So there's something in here that is going to register a media data service as a service to the system. We don't have to include all interfaces that are in the file. It turns out that this is the only interface that we're going to implement, but we actually only export the interfaces that are going to be used as a service. Let's take a look at the implementation class. Again, that's a library project. The source file is in a package, and here's our media data service. Now this particular data service implements the interface, of course. And as I said earlier, this is really just a fake implementation. So I've got some initialization code here to initialize all of the data that you're seeing. This is the definition, the initial definition of the data that we've got. And we're initializing our media objects and so on. Now, this is in fact why we need the linkage to the real domain objects, is that this particular implementation, we have a new media, and this is where we're actually creating the instance of the media object. So new media right here. So we need access to the actual domain class here so that we can create it. But we're actually returning it as an iMedia interface. So the external interface has no usage at all of the actual implementation classes, but this particular internal ones does use the domain objects directly. Turns out that the reason that we need to link these together in this manner is partially due to the way that LCDS uses the register class alias for the classes. It's possible that in the future this linkage may change. So as you see, if you just browse through the code at your leisure, it's just simple implementations of data structures for the gets and get operations and so on. The Gravity configuration for our bundle is of course in the manifest directory. It's a source directory. Here it is right here, Hello Gravity Data Service Bundle GXML. And let's just expand that so we can see it all. So as expected, this is a bundle definition of the data service interface bundle.swif file. Again, even though this is a library project, we will extract out the SWIF as a linkage later on. Now note that this was the parent domain. We're going to have a parent domain Hello Gravity domain model. If you remember, the domain model registered its domain under this name, and we're going to say that we want to parent ourselves to that domain. This allows us at runtime to have access to the domain classes that are defined in the parent application domain. They don't have to be part of ourselves. We get them from our parent. So this bundle is importing a couple of classes. So these are the services that are needed within this particular environment, and the beans are the services that we're going to export. So here is our service. We're going to export a service. We're going to export it under this interface name, which is the iMedia Data Service interface. So that will be the service name that it gets registered against. And this is the implementation class, iMedia Data Service, which is this bean right here, the class that creates it. And note that this is an init method. So this is new syntax. And what this one causes is the bean, after it's been initialized, an initialize method will be fired. And this is what's causing our data to be actually populated in this particular sample. I would like now to take a slightly closer look at how the asynchronous nature works within Gravity, specifically the iTokens that we've been using in our interface. So as we showed earlier, this is a service interface that is going to be used by the media manager in the domain level. So let's go back and take a look at the domain where this is used. So that was our media manager right here. And you'll note that this was expecting the media data service to be bind injected. So this is the configuration that we've seen earlier. So we're going to get an iMedia data service, and if I take a look at that right here, when this gets injected, this setter will of course fire, as long as we've got one. Once we've decided that we actually do have a valid media data service here, we're going to use it and do the getAll call, which of course returns an iToken. So the iToken is a asynchronous result. So we've got this token back, but it hasn't finished the operation yet. So what we do is we take the token, add a success handler for getAllMedia handler. If it's successful, if this were to fail, the fault handler would call instead. So let's take a look at this success handler, getAllMedia handler. So this getAllMedia handler is being passed an all projects iList. Well, how did it know that? So let's just go take a look at what getAll is doing. So if we take a look at the getAll, it's an iToken, but our implementation class for that, and it should be part of the documentation for these services when you create them. But the implementation class for our getAll is here, which we just showed you a moment ago. So find getAll. So there it's returning the token. But you'll notice that what it did is it returned an immediate success token with the projects that it found. So this particular one, it just ripped through our list, created an iList and so on. So it created a list for ourselves and returned it here as a token. So by the time it gets to the user of this particular token, which was our media manager here, we've got our success handler, and it has simply passed the list of projects. So it turns out it's a very clean, easy to use interface to access this. Once we've got the media this handler has been called some later point in time, of course, because of the asynchronous call. This list is assigned into a local variable here, this media list. The media list, of course, is bindable, and the normal flex bindings take over. And we're also, once we've got our list, we've decided if we've got at least one, the list is not 0, we're going to use the first element in the list as our active media element right here. And again, it's a bindable element. That's why when we first launch our application, we have data, and the first selection is the first element in the list. At this point, we've successfully created the domain interface and bundle and the data service interface and bundle, but these things are all still from library projects, are actually just SWIC files that have been created. Now we need, though, the SWIC files. So the way that we do that is when we're linking it into our top-level main application, here I can go to my properties and take a look at the FlexBuild path. So what I do is I come along and I link in the libraries as just as if they were normal libraries, but I change the link type to RSL. So I'm just going to go ahead and I'm going to delete the domain bundle interface and re-add it just to show you how you would do this for the first time. So let's remove this. It's the domain bundle that I'm going to take away. So this now simulates that the domain bundle hadn't been added yet. So what I would do is I would say add project, and you'll see that of course that's one of the ones that's available to be added. So I'm going to say OK, add that in. But notice that when it adds in, it says link type is merged into code. Well, that's not really what we want. I don't want to just take those classes and merge them into this library. I need to create a SWIC. So I can do that by double-clicking on that, right on the link type entry, and that allows me to change the link type here. I can change link type, change that to runtime shared library, and part of what I do there is I can say within that, what do I want to add? And here's my deployment URL. So this is how I can extract a SWIF and get for runtime linking out of the SWIC file. So it's the same name .swif, and I'm automatically going to extract it. So I do that, say hello. So now my link type is RSL. So this is actually something to double check. If you're finding that your things aren't linking or you're not finding libraries, go back and double check all of these things to make sure that you really do have RSL everywhere. It's very easy to miss this. I've got RSL for all of these guys. Now that means that I should be able to come in when I say OK on this. The output directory of my Hello Gravity main, bin debug, should see a SWIF file for all of these. So Hello Gravity domain, bundle, GXML, and SWIF, interface XML, and SWIF. By the way, one of the reasons why we have picked underbar for our separators like this is such that we can get this nice alignment so that it's easier to double check. If you start using dashes and various other things, camel case names that we have tried, we hadn't get a combination where we could get the GXML configuration files and the SWIF files to all align nicely. There was always something wrong with the configuration, and using underbars works quite nicely such that you can have you can quickly scan your output directory and make sure everything is in place. You got your configuration file is there, your SWIF file is in. I do still actually need to show you how we brought the manifest files over. So if you go into the properties one more time, the source path, you'll notice that we just linked in the manifest files from the other bundles directly here as source files. This is some trickery with FlashBuilder such that we can use the existing FlashBuilder environment to copy over the manifest files and unpack them as RSLs to get the SWIF files out of the SWICs and all of that stuff. It's possible with the Maven builds or Ant builds you can do something, do this more directly, and hopefully with some new tooling in the future this will be simplified. And running our application one last time, we should have a completed application where we've described all of the various parts that you need to build it. So enjoy using Gravity to build modular applications. Remember, you can use your own frameworks, your own techniques to do this, and of course your own judgment as to what should be a module and what should be together in one module.